This is the solar system. There are 8 planets traveling in elliptical orbits. Earth is one of them. For these planets and comets to travel around the Sun, there must be some sort of force being applied because there are no strings or wires. In 1687, Isaac Newton put forward his theory of gravity, stating, "There is always a force of attraction between two objects caused by the masses of the object." He called this the gravitational force and suggested that the size of the gravitational force depends on the masses of the object and the distance between them. The greater the mass, the stronger the attraction force. The greater the distance between the masses, the weaker the force. Our sun is huge, so the gravitational force between the sun and the planets is also huge. It's what holds our solar system together and makes the planets follow their curved paths. Planets that are closer to the Sun have more curved paths due to the larger attraction forces. The gravitational field strength is the strength of gravity on a planet or moon. There are two factors that affect the gravitational field strength: the mass and the radius. Larger the mass or radii, larger the gravitational field strength. The Earth's gravitational field strength is 10 Newton per kilogram. Satellites are objects that orbit a planet. There are two types of satellites: natural satellites, also known as moons. Earth has one moon that takes about 28 days to go around the Earth. Many planets have moons. Mars has 2 moons, while Jupiter has more than 60. Moons have circular orbits due to the gravitational forces from the planet. Artificial satellites are the man-made ones that humans launch into orbit around the Earth. We use these satellites for communication and to monitor tiny details of the Earth and many more. Comets are large rock-like pieces of ice that orbits the Sun. They have elliptical orbits, so at times they are far away from the Sun, and at the other times they are very close to the Sun. Orbital speeds of planets and satellites can be calculated using the speed equation. For distance moved, you must take the circumference of the orbit, so 2 pi r, and for the time period, it is the time taken to complete one orbit. So orbital speed is 2 pi r over time period.